Hello and welcome to the next lecture under the module Stats the way to do it. As you know, the previous video was on simple linear regression. So, this is the extension to that regression analysis when we are interested in knowing the relationship between more than one variable. So, the limitation of SLR was you can study the relationship of y with only one x. So here in multiple linear regression we will understand the relationship of y with more than one x. So welcome to today's video on multiple linear regression, which is also known as MLR. So the bottom line is simultaneous relationships in data. Moving to the agenda of the lecture, first we will understand what is simultaneous relationship. Then again in the context of performance of swimmer, we will find the factors affecting performance of swimmer. Then we will see the data collected. Then steps to develop MLR model. Then solving equations in scientific calculator. Then we'll see MLR model and its interpretation. So coming to simultaneous relationship in data, now let us take a case of boxer. So you also always know that in a boxing ring there are only two boxers fighting with each other. So you can refer this match as SLR when one boxer is fighting with only one boxer. So that is SLR. We are understanding the effect of one X on one Y. So in the context of analysis of swimmer, the measure of betterness was swim lap time, and in that video, the link of that video will be here in the captions. We understood the relationship of age on swim lap time. So SLR model only gives the relationship with a single factor, that is age. But in real sense, many factors together contribute to the swim lap time. So it is something like one fighter in a boxing ring is fighting with more than one fighters on the opposite side. So you can say many people are fighting with a single boxer. That is the real life case. So swim lap time is not only depending upon the age, but along with age there are simultaneously number of factors like sex, weight, height and many more. So in such case MLR models are more realistic because it provides combined effect of multiple factors at a time. Now coming to performance of swimmer, you already know, but I will reiterate for the new viewers of the video that for performance of swimmer, we have selected speed of swimmer or lap time as a measure of betterness. So here we have selected lap time as a measure of betterness, and our target is to minimize the lap time. Then what can be the factors which can affect the lap time? So factors related to swimmer are age of the swimmer, sex of the swimmer, weight of the swimmer and height of the swimmer. Some factors related to systems will also play a role, like length of swimming pool or swim lap, temperature of water, ambient temperature and terrain. So coming to the data collected for swimmers, this is again repeated but I will reiterate. Swim lap time, the data is for 10 swimmers as a sample. Then age of the swimmer, height in centimeter, weight of the swimmer in kgs, water temperature in degree Celsius, and ambient temperature in degrees Celsius. So as I said, we can evaluate the combined effect of simultaneous factor through MLR. But if the factors are more than 2, then we will need some software like Excel, Minitab or SPSS for getting the MLR model. But manually if we have to solve it, so MLR can be solved manually with 2 factors. So in this video, I have covered the MLR model for 2 factors only. If the factors are more than 2, we have to go and take some software support. So you can wait for upcoming video showing multiple linear regression model for more than 2 factors. As of now, we have selected measure of betterness, that is Y, as swimming time or lap time you can say, and we will understand the relationship with 2 factors simultaneously. So we will choose height and weight because age we have already covered in the video of SLR. So here we will take 2 factors, height and weight. So height as x1 and weight as x2. Now coming to steps of developing the MLR model. So MLR equation, step number 1 is general MLR equation is in the form of again straight line, but here the number of factors are equal to the number of slope coefficients while the intercept remains single only. So general MLR equation y equal to b plus a1 x1 plus a2 x2 up to an xn when there are n number of factors. But as of now, as I said, solving manually the MLR equation is possible only up to 2 factors. So we are selecting this equation only up to a2x2. Then step number 2, there are 3 standard equations for MLR. Now listen very carefully because there are 2 options with you. Either you memorize these equations 1, 2 or 3, or if you want to absorb this equation in your mind, then you must see how these equations are derived. So listen very carefully. If possible, you can rewind this particular set of time repeatedly to understand how these equations are generated. So see, as I said, the general MLR equation up to 2 factor is y equal to b plus a1 x1 plus a2 x2 till here only. Okay, so how I get these 3 equations 1, 2, 3, which are standard equations. So either you memorize it, or if you want to understand the genesis how these equations are derived, just look at this explanation carefully. So for equation number 1, we will multiply the general MLR equation by summation. Now see, I said this is the general MLR equation. I will multiply it by summation, so it will become summation y. Then here there is no factor apart from b, and b is a coefficient, so there will be a nascent summation, so I will replace summation by n, number of observation, so it becomes nb. Then multiplying a1 x1 by summation, so a1 I will take aside, it will become summation x1, and a2 I will set aside and it will become summation x2. So in this way, multiplying the general MLR equation by summation, we get equation number 1. Then for getting equation number 2, you have to multiply equation 1 by summation x1. Now see carefully, this is the equation number 1 and we will multiply it by summation x1. So see, summation y multiplied by summation x1 will become x1 dot y. Then n is not needed anymore because I am multiplying b by summation x1, so it will become b summation x1. Then a1 summation x1 is already there. Again I will multiply by summation x1, so it will become summation x1 square, plus a2 summation x2 is already there, multiply by summation x1, so it becomes x1 dot x2. In this way we get equation number 2. Now for equation number 3, again we will use equation number 1 and multiply it by summation x2. So again it will become x2y plus b summation x2 plus a1 summation x1 x2 plus a2 summation x2 square. In this way we get these three equations, and if you know how they are derived, there is no need to memorize it, because memorizing it will be a short term solution. But if you understand this derivation, then you have to memorize only this equation and you will be able to generate these three equations on paper. So data collected for swimmer. We already know we had selected y as swim lap time, x1 as height and x2 as weight. Now what are these five other columns? So these five other columns we get from these three equations. So in this equation, whatever I will need, I will make it as a column. So checking from here, do I have a column of y? Yes, we have. Do I have a column of x1? Yes, we have. Do I have column of x2? Yes, we have. So we have this three column ready. So for equation 1, we don't need any additional column. Now for equation 2, do we have column x1y? No, so we will generate it. Do we have column x1? Yes. Do we have column x1 square? No, so we will generate it. Do we have column x1 x2? No, so we will generate it. So you see here, we have generated x1y, x1 square and x1 x2. Similarly, for equation 3, do we have column x2y? No, we will generate it. We have column x2. We have column x1 x2, we made it here, and we don't have x2 square. So again two columns I will generate, x2y and x2 square, x2y and x2 square. So in all we have to generate 5 extra columns, which is needed in equation 1, 2, 3. And how we will fill the values in the table? So x1y will be a simple multiplication of x1 into y. Then x2y will be a simple multiplication of x2 into y. x1 x2 is the multiplication of x1 and x2. Then x1 square, that is height square, x2 square, that is weight square. In this way we will fill this table with all the values. And as we know in the equations, I am needing the summation of all values. So entirely this table we will have last row as summation of all the columns. So now I have summation of all the columns. This is summation y, summation x1, summation x2, summation x1y, summation x2y, summation x1 x2, summation x1 square and summation x2 square. Now we already have three equations, equation 1, 2, 3, which we derived. Just we will put these summation values in equation 1, 2, 3. And likewise my equation 1, 2, 3, when I will put the values, it will become equation 4, 5 and 6. You can see the values here, 269.8, 10, 1730. These are the summation values from this table. This is the bottom line, summation values. So now I have got equation 4, 5 and 6. Yes, now coming to solving this equation. Now solving two simultaneous equation on paper manually is very easy, but it is cumbersome to solve three equations manually. So we will use the scientific calculator for solving this equation. Now look at the cursor. This is the general scientific calculator. You have to go to mode and equation mode. So I have used one mobile app. So when I press mode, this list will open and here you will get equations. So first is solve system equation with two unknown. So that is useful for SLR, but we will say solve system equation with three unknowns because we have three equations. So we will have three unknowns, and as soon as I press this mode, that is solve system equation with three unknowns, such screen will be visible. So what is there in this screen? There are four columns and three rows. So now I have to put the blue color values, that is only summation values, okay, in this particular table. Okay, I will also show the demonstration, don't worry. But you can see the blue color values. In every equation there are four values. So equation 4 have these four values, equation 5 has four values, and 6 has four values. So all the 12 values I will put in here. But here there is a glitch. So the value which is before equal to, that I will be putting in column D. Okay, so I have to start putting the value from coefficients, that is here. So listen very carefully. First of all, I will put value starting from here. So 10, then 1730, then 685, then 269.8. Then here 1730, then 299,896, 119081, then 46532.3, then 685, 119081, 47481, and finally 18363. So you have to put the values like this. You can tally here. So 10, 1730, 685, 269. So remember this pattern. Equal to value you have to put in the last column. Now as soon as you put in this calculator all the values, just you have to press equal to, and first value you will get for B. So this value came out to be 222.130 directly. Then second value we get for A1, so it is minus 1.764. Third value is A2, that is 1.608. Now it's time for calculator demonstration. So I will definitely show you the demonstration. Just a minute. So let us have the demonstration of calculator. So I will go to mode, then solve system equation three unknowns, and you will get this table. Now as I explained you, and it is also visible in the side screen, we have to put the values starting from coefficient. So I will start from 10. Just I will be keeping pressing equal to button after entering a value. So 10, 1730, then 685, 269.8, then second row 1730, 299,896, 119081, and 46532.3. Then last row 685 119081 47481 and 18363. So I put all the 12 values in a table. Now first time I will press equal to and I will get a value of B. You can see on screen. So value of B is 222.130. So I have already written the value of B on the slide. Then second time I press equal to, the value is minus 1.764. So it is a value of A1. Third time I will press equal to, the value is 1.608. So that is a value of A2. In this way you can use scientific calculator to solve three equations and directly get the value of B, A1 and A2. Now let's get back to the slide. So we have got the value of B, A1 and A2. Now we will put this value in general MLR equation. So our equation was y equal to B, A1x1 plus A2x2. So we got these three values from the calculator. Directly we will put it in a model. So as the value of x1 was in minus, this plus sign will convert to minus. And my final equation will be swim lap time will be predicted on the basis of 222.130 minus 1.764 into height of the swimmer plus 1.608 into weight of the swimmer. And now this equation is called MLR equation or MLR model. And this model can predict the value of swim lap time on the basis of any value of height and weight. So this can facilitate again the decision making. Now let us come to interpretation of MLR model. So this is the MLR model which is obtained from calculator. So now how to interpret this model? Now I have made an attempt to show you with the help of these pictures. Now look at this left pictures. It is about height. So a man is having maximum height, then there is a lady with medium height, and then there is a girl with lesser height. So the objective is to minimize the lap time and the coefficient of height is negative. So the negative coefficient is already helping the swim lap time to be less. So it is termed as complementing factor. So in this equation, height is a complementing factor in minimizing the swim lap time. So more the height, lesser the swim lap time. So here we can say that in this figure, the person with maximum height may have the minimum swim lap time based on the height. Similarly, on the right figure, we are talking about weight. So a lady is there who is the slimmest, then a person with medium weight is standing in middle, and to the extreme right there is a person with heavy weight. But the weight coefficient is positive and we want to minimize the lap time. So we can say that weight is a resisting factor in minimizing the swim lap time. So the person having the maximum weight will have the maximum swim lap time. So in this way, the MLR models can be interpreted and likewise the decisions can be made about the relationship. So that's all. Thank you for this lecture. This lecture was about multiple linear regression model of two factors, but if you want to do the MLR for number of factors at a time, a video will definitely be released. Stay tuned.